Hey guys, what's up? Sa here. So this week I had to, as a quick update on a new devlog video. This week I had to take care of some important stuff in, well, real life, as you might call it. So it doesn't mean though that I didn't work on this. In fact, I've been working extensively on the navigation. Um, the only problem is that I didn't have much time left for answering questions on Discord, so might have been I might have been a bit MIA there. So sorry for that. But once this navigation stuff is done, I'll be back on schedule, working on crafting strategies and all of that. It's just that well, it's definitely been more difficult than I anticipated to make the navigation work due to several problems I've encountered. Mostly, it's a matter of, well, there's a few little problems that I've encountered that made the entire thing a bit more difficult than it should be. For example, Reborn Body actually detects navigation walls, which are invisible walls. So let me give you an example. Go to Islands. There's one there. Yeah. So basically, I've been trying the entire week to make the pathfinding more efficient. If you remember my last video, the pathfinding was working, but it was very slow, about 500 milliseconds per path found. Yeah, so the first problem I encountered is that Ribbon Body will actually, the Raycaster in Ribbon Body will actually detect a wall, an invisible wall, where the ground navigation ends. So you can see that the player can go through here, but if I dismount, then I can't, right? Because there's a wall there, a nav wall, nav mesh wall. So the problem was that even when flying, if I raycast from here to there, it would find a hit, but the hit actually doesn't exist. So I was having problems like the meshes that I got from the game don't have those walls. So the Pathfinder was trying to do stuff like get out of here and then move over there. But then everybody will say, "Oh, there's an obstacle there. I can't go there. Recalculate with these obstacles," and the Pathfinder would, it was just a mess. Um, so yeah, that was one of the problems I found. The other problem I found is that the meshes that I got out from the game, not all of them are actually positioned correctly compared to the actual game. For example, let me show you one. Most of them are. Most of the mesh is fine. There's a few of them, like this one. This is the. Let me see. This is. Yeah, this is the one that was giving me trouble here. This mesh is actually like turned around, but I couldn't figure out what the error is on the rotation. To be honest, so the problem is that there was a dragon that Lisbeth was grinding here, and in the game this is clear, right? So the Pathfinder, Lisbeth would be something somewhere around here. They would ask the Pathfinder to go to that dragon, but then the Pathfinder would time out because there is no way to get into the model. Like, there is no path to get into there, so the Pathfinder would expand nodes around it and then time out. So I had to figure out what to do in those cases. Basically, right now I have to correct the mesh manually. What I do is I made some logic on the Pathfinder that if it times out due to something like this, it'll save the start point, end point of the path and all of that, so that I can later just go into that folder and see all the saved paths that timed out, and then go here and see where the path is, and delete this and remesh the zone. Which so meshing these zones. So basically, this is what I've been working most on this week, is to make the entire Pathfinder more efficient, right? The problem is that these zones are big. They're basically the nodes in the Pathfinder's nav mesh are 4f in length. So they're cubes made of 4f, 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 right? So there is 137 million nodes per zone. And so I had a lot of problems with optimization because, well, the first way I've gone through a lot of refactors throughout the week. I went from obstacles to free nodes to obstacles again to trying a hybrid approach where the super nodes were free nodes and the unit nodes were obstacles. Um, I tried different ways of representing the graph. You know, it's been a it's been a lot of starting over, I guess, on this kind of stuff. But basically, I managed to find a way to represent. So one of the things that I discovered, I guess you could say discovered, but I guess I just found out is that well, after thinking about it, there is a way to represent the nodes in the zone without their XYZs, because initially what I was doing is I was saving the graph, the nodes in the zone where the Pathfinder can pathfind by their XYZs. It makes sense, right? They are somewhere in the zone. They have an X, a Y, and a Z. That's 3 floats. Problem was there were 2 problems with that. First, it was taking way too much memory when you consider that a single zone has about 1,500,000 nodes once compressed by supernodes and once removing the obstacles. So it's not 137 million nodes, which is the maximum that it could have, but still 1,500,000 vectors in memory was taking way too much space, especially considering that I was saving them on a hash set. So something like this. Let me write some stuff here. I was saving it on something like this, right? Oops. So something like this, right? This was taking way too much memory. First of all, because not only is it a lot of data, right? But the hash set I discovered, and I had to dig around a bit on the Microsoft documentation, all of that for the hash set, because this is a standard collection. And the hash set actually takes about 20 bytes per entry extra. So it was getting, imagine that, 1,500,000 vectors per zone, and then 20 bytes extra to the XYZ floats, right? So it was taking way too much memory. I in fact ran out of memory on the server. So I had to find a different way to represent the graph. Now, of course, what I did was, after thinking about it, I discovered that you can actually represent all the pathfinding graph and everything you need for pathfinding by a single int. So every node can be represented by a single int, and that's because of the regularity of the octree. So I tried different ways to do it. Ultimately, I managed to find a way to do it by using a base 9 number system instead of base 10 like we usually use on most stuff. 0 to 9, and then when you reach 10, you increase the digit position. So in base 9, you go from 0 to 8, and when you reach 9, it increases the digit position. So that's what I'm doing here. Well, it's actually base 8, I guess, because I don't use the zeros. But yeah, that's basically the idea. Oh wait, no, I actually use the zeros now that I remember. I use the zeros to represent supernodes, because not all nodes have all 8s in ones. Well, that's a minor implementation. It all doesn't matter. So basically, the way I do it now, if you see the measure, let's just start it on the zone. If you see the measure, look at this number. It's checking all the nodes in the area, right? But you can see that in the number, this is the node that it's checking right now. So it goes very fast, right? Because it checks about what 3,000 nodes per cycle, and we're having about 40 FPS. Yeah, it goes very fast, but you can see that the number is actually in base 9, because once a digit position reaches 8, then when it goes to 9, it overflows to the next one. So that's a way to represent the nodes on the graph by a single int, and that has 2 benefits. First, it made memory usage much better, right? Instead of doing this, I could just do this, and that's my graph. and that actually occupies very little memory. It's still a little bit because the hash set again adds about 20 bytes per entry. It's still a little bit large, but it's manageable, right? Um, then the second benefit I was having is that let me show you. Is that on the performance tests using the profiler, I found out that one of the biggest parts making the entire pathfinding search slow was checking if a node is in the graph or not. So basically, I would do something like this, right? Let's say we have a node, our node equals 30, whatever. Then I would do something like this: graph contains 30. So I was doing that, thousands of times per search, hundreds of thousands of times. And when I was doing it on hash sets, when I was doing it on vectors, so the vector has, the equality members overridden and all of that to make it work. But when I was doing it with the vectors, the profiler was telling me that the contains method of the hash set was taking the grand majority of the processing time of the pathfind. And so I started digging up. That's when I started digging up on the hash set. And what I found is that the contains method of a hash set, so graph contains something like that, right? The contains method on a hash set is kind of O1, where the problem arises when there are a lot of hash collisions. So the problem was that by having 1,800,000 or 2,000,000 nodes on the hash set, I was getting a lot of hash collisions. And what the hash set does is when there's a collision, it resorts to the equals methods of the type. So if we go to the vector here, to the equality members, so it was actually using this a lot, and that's really bad because it's doing a lot of operations just to find the existence of a node on the graph, right? Instead of using the hashes because of the collations, it was using this shit here. And the profiler was the one telling me that because the profiler was telling me, hey, the hash set is invoking this stuff a lot. Like not all the time. Most of the time, it was handling with the hashes, but there were a lot of collisions. So basically, when I switched to ints here, that also got way faster because that suddenly, right, there are no collisions because all the ints were unique, and the hash of an int is just an int. It's the int itself, sorry. So that made it way faster and use less memory. And so you can see, for example, the benefits. Let's run a test run here. Yep, 300. So you may remember this test I did on the previous video 1 week ago, and it took the Pathfinder about about half a second, for 500 milliseconds or so to find the path. Now check this out. About 40 milliseconds, 35 or something. Much better than before, right? A considerable speed advantage, and the memory stays constant. I was having memory leaks, in fact. Yes, you can have memory leaks on managed code. I was having memory leaks with the vectors and the references. It was a mess. The entire week I've just been optimizing and fixing shit with this. But finally, it's fast. I could reduce. I tried different things, and I could reduce this to about 16 milliseconds by caching the adjacency of nodes. But the problem is that, well, let's make a few napkin numbers here. I can't cache the adjacency of nodes like in a traditional, graph where you say node A goes to node B and node C, right? I can't do that because there's just too many nodes and too many adjacencies. So for example, a unit node would have a maximum of 6 adjacent nodes, right? One for each direction. But the supernodes, if they are unlucky in where they are on the map, a supernode can explode Let me turn this off. Oh, no, let me turn it on. A supernode can explode to hundreds of adjacent unit nodes if they are just unlucky enough. Let me try to show you what I mean. So that was a problem because suddenly you have, for a single zone, you have what? 2 million nodes, and then those 2 million nodes have minimum of 6 adjacents. Well, if some of them are obstacles, maybe you can trim down that list. But some of those nodes are going to have hundreds of adjacents. So it basically was just too much memory. If I had unlimited memory, caching the adjacencies of the graph would be a huge speed up, because instead of the Pathfinder having to calculate, let me go to the octree. Instead of the Pathfinder having to calculate the adjacencies on the spot, because that's what it does, right? The Pathfinder uses the octree to calculate the adjacents of a node purely by mathematical operations. But that's the major limiter right now. If I were to cache, this is the expansion right here. So if I were to cache this, if simply I make a map for this node to this collection of nodes, which remains constant as long as the graph remains constant, then the speed up, it's incredible, right? It goes down to about 10 milliseconds. The problem is I can't do that, and because of the memory limitations. So that was one of the major problems I was having. But I think the other performance tune-ups have made it bearable. Honestly, 50 milliseconds to find a path is doable by the server. Of course, the server is not as powerful as my PC's processor, it turns out. But still, using one of those high CPU, and that's something I also did. I made actually 2 servers this week, one in Vultr and one in DigitalOcean. Yes, I know I could get a dedicated server for relatively cheaply on other places, but to be honest, I just don't want to work on it on my free time. So something managed like Droplet is just way better for me. And honestly, those. So I made a comparison between the Vultr droplets and the DigitalOcean high CPU droplets, which they just released recently. And the difference was about 60%. So the DigitalOcean high CPU droplets were about 60% faster than the Vultr droplets. And even though the Vultr droplets gave me more memory, I decided to go with the high CPU ones because of that. And so, for example, that test that my PC does in about 40 milliseconds, the droplet. I just have too much shit. The droplet takes about, I don't know, about like 20 milliseconds more, like 30 milliseconds more. Basically, if anything is below 100 milliseconds, I think it's fine. I think it's doable. Yeah, I think it's fine. So I've been, it's been it's taking a lot of time to do the navigation, I'll admit. It's a very interesting project though, so that's why I'm doing it mostly. And yep. So this past couple of days, I finally managed to integrate it into Ribbon Body actually, and so Lisbeth can finally freaking fly. Let me show you. Let's go to another area. I've been testing it with the dragons and Churning Mists. Yeah, there's still a few fine tuning to do. There's still a few problems. But yeah, it's mostly working now. I'm confident that I'll be able to release it soon for general testing. What else? What else I can talk about on this video? Well, the area router is working. That's something I haven't talked about much, but it's basically a system that finds routes between areas, between zones. and it uses everything: the ferries, the airships, the zone transitions, teleports, either networks. Basically, searches for routes and picks the fastest route. But you can see that Elizabeth is finally grinding while flying. You can see that it gets paths with let me pick one here, with a 233 millisecond delays. Sometimes it gets stuck. Remember when I told you that? So the meshes that I exported from the game are not complete. So basically, the obstacle raycaster is still in operation, and it sends the obstacles to the server. The server saves them, recalculates the routes. You can see it happen right now. But the meshes help as a base, right? So that you don't have to mesh the entire zone. Just little parts that the mesher missed because of the incomplete extraction of the game's meshes. But basically, like this part, I guess it didn't have that part. But you can see that it learns like the first iteration. It's a combination between the meshes as a base, and then the learning portion to complement it. Yeah, you can see that it's flying finally. Yeah. So I'm planning to fine tune it a little bit more. Test a little bit more other hotspots. See where it's having problems because the mesh is wrong. Remesh, delete models, remesh, and so on. Um, and I do hope to release a public test. If not today, then tomorrow or past tomorrow. It's probably going to be no more than tomorrow. Then I'm going to start working on the crafting strategies because that's something that a lot of people seem to be asking for. I also have to fix the Chinese versions of both Lisbeth and Agile, which is a pain to have two versions of the same software, just because Reborn Body changes and the entire API changes. But yeah, I'll get back to that soon. Hang on in there, guys. This is a transition stage. Right now, Stormblood changed a lot of things. You can see it here, learning the path. So yeah, right now Stormblood has changed a lot of things. So things will be broken for a little bit more time, but it's getting there. It's getting there, and that's it, I guess. I'll see you next video.